To another episode of The Joys of Mathematics. If this is your first time watching, then here's your chance to go and grab a notepad and pen so you can work along at home. And if you are a return viewer, thanks for coming back. Now, today we're going to work through something that's a little more abstract in its creation, and we're going to do this to hopefully see that sometimes you can't always trust something on its first impression. Sometimes you need to look a little bit closer because often things are not as they seem. So keep in mind that this piece today is going to be more of an abstract artwork than a conventional one. So I've got my trusty titanium white colour here, and let's get started. The first thing that we're going to do is we're going to let A equal B. A and B are our first two characters, and they are variables. They could be anything that they ever wanted to be. They have the whole world as their oyster. But today, A and B have chosen to be exactly the same thing. Now, as we go along, don't be afraid of the mathematics here. I'm here with you and I'm going to help you go through it. Well, what we're going to do is times both sides by B. That will give us A times B is equal to B times itself, B squared. So we've added a couple of happy little B's here to this line. We added B's to both sides, so that's fine. We can add or multiply whatever we want as long as we do it on each side. Same with division and subtraction. There's a moral of the story here: only do to others what you want done to yourself. And when you've got two sides of an equation, anything you do to one side, you have to do to the other. Now let's add some more happy little B's, and in fact we're going to add another B squared to each side of this equation. Alright, got a lot of happy little B's. Let's just simplify this. B squared plus B squared could just be written as 2B squared, and this line, or this side, stays the same. Now you might be sort of wondering how this is going to end up anywhere, but just trust me, sometimes you need to just go where the wind blows you, and it is pretty windy out here in the garden today. I hope that doesn't cause too many issues, but let's just follow along with the drift of the wind here, and you might have to trust me a little bit. Okay, we've added B squareds. What if we do, we've got an AB, what if we subtract the same term from both sides? And that term is going to be 2AB. All right, let's do it to both sides. This term that I subtracted from both sides could have been literally anything, since I did it to both sides and it's going to make the result the same. But up until now, we haven't done anything illegal with our algebra. This is all fine. Okay, so if we have 1AB and we're taking away 2 ABs, how many ABs do we have left? Well, the answer is we'll still have our B squared and minus 1 AB. And on this side, we've got 2B squared minus 2AB. All right, what I want to do next is to factorize this line, and I'm going to continue up here to do that. So there's one common term to both sides, and that is B squared minus AB. On this side, we could take a 1 out of the bracket if we really wanted to. It's somewhat unnecessary. But we have 1 times B squared minus AB, and that is equal to, well, we can take a 2 outside the brackets now, 2 times B squared minus AB. Getting a little close to the edge there, but I think we're all right. Okay, so now we've got this line still, nothing illegal has happened. If you want to check my algebra, you can go through there. But now we have something. All right, we have B squared minus AB on both sides of the equation. What we may want to do is to recognize that if we divide both sides by the same thing, that's all right. Like, we can divide both sides by B squared minus AB, and that would be the same as cancelling out this term. If we'd cancelled out this term in brackets, then what we have left with is that 1 is equal to 2. Now, here's where it appears to be pretty abstract, and in fact, something doesn't quite add up here. I'm going to put a little box of shame around this, because this means we've done something weird or something illegal along the way. We can't just suddenly have 1 being equal to 2, because that would fundamentally change so many things about mathematics. We rely on 2 being exactly double 1 and not being equal to each other. So have a little look at the algebra and see if you can identify where we went wrong and why. Don't worry if you can't get it, I'm going to show you in just a second. But if you've formed your opinion, then let's have a look. I stand by that all of this algebra is correct. The issue comes in at this line here. Now, we divided both sides by b squared minus ab, and that would be fine as long as b squared minus ab, the stuff in brackets, was not equal to 0. If this stuff was equal to 0, this would amount to dividing both sides by 0. And as you might know, dividing by 0 is kind of forbidden in mathematics. The answer to that is undefined. When you start dividing by 0, things in the universe stop making much sense. You could already sort of argue that the world doesn't make a lot of sense to us. You know, good things happen to bad people all the time, and there's a lot of things that are unexplained. But right here, this would give us some weird things. Dividing by 0 leads to all sorts of things, such as that 1 is equal to 2. And frankly, this is nonsense, so we need to sort this out. So let's have a look. B squared, since A and B are equal to each other, is actually the same as A times B. So this in brackets is in fact equal to 0. And what we have on this line up here is that 1 times 0